Let's take a look at some probability problems involving cards. A standard deck of cards contains 50 cards as shown in figure 9. So for those of you familiar with a standard deck of cards, on page 40 you'll actually find a picture that looks something like this. This is not the exact photo, but it looks something like of all of the decks of cards, all in a deck. So if you're not familiar with a deck of cards, that's definitely something you want to check out on page 240 to familiarize yourself with the different types of cards. We want to find the probability of selecting a heart or a club. Well, the first thing we do know is that there are 52 cards total. If you are to go over to the picture on page 240 of your textbook and count up, you could see that there are 13 hearts. This is my heart row right here. For this picture, we're going to ignore the bottom two. They have two jokers in the deck, which is not what we want because we have 52 cards. But we have 13 hearts total. So we have 13 hearts. You'll also notice we have 13 clubs. Now, if you'd like to put this in the calculator to add these together, you can actually divide 13 divided by 52 is 0.25. Remember, a fraction just means division. And you are welcome to create your probabilities as decimals, or fractions, depending on what you want. So that's totally up to you. Find the probability of selecting a heart, club, or diamond. Well, we've already determined there are 13 hearts, 13 clubs, and you can go back over to that picture and you can verify, if you would like, that there are indeed, you could count them up, there are 13 diamonds. This is my diamond row right here. There are 13 of them. So I can go ahead and add in my 13 diamonds to figure out the probability of getting a heart, club, or diamond. Now this is actually 0.25 if you want a decimal route, and sometimes it's easier to go the decimal route, then you don't have to worry about simplifying fractions to give a probability of 0.75. The last one's a little bit trickier. Find the probability of selecting an ace or a heart. So we go over to our picture here and we say, okay, aces. 1, 2, 3, 4 aces. Okay, I'm good with that. I have 4 aces out of 52 cards total, plus I have 13 hearts. We've already determined that in parts A and B, but you have to be really careful. We've actually counted up a card twice. If you notice, there's what we call an overlap card, or an ace of hearts. I counted that ace of hearts up when I counted all the aces. I also counted it when I counted all the hearts, and I don't want to count it twice. So we're going to subtract out the number of cards that meet both criteria, or in this case are an ace and a heart. So I'm going to subtract out 1 over 52. Now for ease and simplicity, I'm actually going to do the math before converting them to decimals. 4 plus 13 is 17. 17 minus 1 is 16. And your bottom number stays the same. Remember, when you add or subtract fractions, you add or subtract the top number and keep the bottom number the same. Then if you would like to bring this to a decimal, you may. It is not a nice decimal like our first one was, but if you'd like to, there's definitely not a problem with that. That is 0.3077. So we've done some probability questions involving cards. Just keep in mind that picture is your friend and it can really help you out.